Assalamualaikum warahmatullahi wabarakatuh. My name is Nurwadina binti Amran. My student ID is 2023-115567.
Hi, my name is Nur Shafika binti Rosli and my matric number is 2023-388467.
Hi, my name is Siti Zuliana binti Zaharuddin and my matric number is 20233999473.
Here is introduction. The data is taken from Drug Information Book from 2011 until 2020. This data is from a survey of National Anti-Drug Agency of the Ministry of Interior. From each drug addict that was being surveyed, the numbers of drug addicts detected among degree students and the number of drug addicts detected in 2011 until 2020 was recorded. The goal of this study is to predictable relationship between the numbers of drug addicts detected among degree students and the numbers of drug addicts detected in 2011 until 2020 by National Anti-Drug Agency. In this survey, we use least square method, which is linear model, quadratic model, and cubic model. And for the table that you can see, it shows that the number of drug addicts detected among degree students and the number of drug addicts detected in 2011 until 2020. And for the table, we can know that the number of drug addicts is Y variable and degree student as a X variable.
Alright, to begin with the linear model, from the data we get before, we can form a equation from linear model, which is y equal to a plus bx. So where y we can get from the data, which is the number of drug addicts detected in Malaysia, and x is the number of drug addicts detected among the students. So we can form the equation like this. Alright, from the equation that we made before, we can make the equation into a metric form. So after like this, and after we make a metric form, we can define the metric form which is m, y, and v like this. Alright, in order to find the value of a and b, we need to follow the formula, which are v equal to open bracket m transpose multiplied by m close bracket inverse multiply by m transpose multiplied by y. So first we need to make m transpose first, and then after we get the m transpose, we need to multiply the m transpose with m, and then after that we need to inverse the m transpose multiplied by m, and then we need to find the m transpose y. So once we get all the numbers, we substitute the numbers into the v formula. Okay, after we find the value of v vector, which are a and b, so we need to multiply the m with the vector v, then we can get this value. And after that, we need to find the error vector, and in order to find the error vector, we need to use formula E equal to y minus m multiplied by v, so we can get this value. And after that, we need to find the error magnitude, so we need to use this formula, and then we can get the error magnitude. Finally, after we get all the value that we need to find, and then we can make a graph of the best fit curve. So the y-axis is the number of drug addicts, and x-axis is a degree student. So we can get the this graph of the best fit curve for the linear model.
The equation for the quadratic model of the best fit curve is y equal to a plus bx plus cx squared. From the equation, we need to convert to the metric form, which is we will get m, y, and v. Then we need to find best fit curve with using formula v, which is m transpose multiplied by m inverse. Then we need to multiply with m transpose multiplied by y. From metric form, we need to find M transpose. After we get M transpose, we need to multiply with M. After we get M transpose multiplied by M, we need to inverse them. After that, we need to find M transpose multiplied by Y. After we get all information that we need, we can find best fit curve using formula V. After we get answer from formula V, which is we will get value of A, B and C. The value of A, B and C, we need to substitute in the equation of the best fit curve, which is Y equal to 20272.9198 minus 187.4977x plus 5.0184 x squared. After that, we need to find error vector using formula y minus mv. After we find error vector, we need to find magnitude error vector, which is we need to square root the total of error vector, and each of them we need to square root it. Then we will get the answer 5353.7573. This is the graph that we plot for quadratic model after we find the best fit curve in quadratic model.
Assalamualaikum. My name is Siti Zuliana binti Zaharuddin. So now I'm going to explain about the cubic model. So for the cubic model, the equation is y equal to a plus bx plus cx square plus dx cube. Next, this is the equation when we substitute the point of m and y. Done. So from the equation before, we will make it in the metric form, and this is the m metric and y metric. So next, we need to find the least square solution by using the equation v equal to m transpose multiple by m inverse multiple by m transpose multiple y. Okay, from the m metric, we make it the m transpose. After that, from the m transpose, we multiply by m. After that, we inverse m transpose m. And for the second step is we find the m transpose y. After we get the value a, b, c and d, we substitute back in the equation the best fit curve y equal to 20272.9198 minus 187.4977x plus 5.10184 x square minus 0.02536x cube. After that, we need to find the error magnitude. So first, we find the error. E equal to y minus mv. So we find the mv. M multiplied by v, and we got the answer. After that, y we minus with the mv we got before. Next, we find the error magnitude by square root all the error value we got before, and we got the answer is 5287.3037. So this is the graph that we plot for the cubic model after we find the best fit curve equation. So from the conclusion, based on the survey that we collect from the drug information book, there are many ways to choose the best method that can be used on 3 models below. So the first type is linear model, and the error magnitude we got is 6089.8. The quadratic model is 5353.75373, and lastly is cubic model, and we got the error vector, and error magnitude is 5287.3037. So the best fit curve in this survey that give the best approximation is the cubic best fit curve, because it has the minimum error in terms of its magnitude. That's all from us. Thank you.